Welcome to physics class. My name is Muhammad Gyasuddin. My dear students, today we are going to discuss about another important topic, derivation of de Broglie hypothesis. That means prove that lambda equal h by mb. So solution hypothesis. In 1924, de Broglie suggested that every moving particle associated with wave. According to this hypothesis, a moving particle sometimes acts as a particle nature and sometimes acts as wave nature. These types of wave is called de Broglie wave or matter wave, and the wavelength is also known as de Broglie wavelength. Okay. The mathematical expression of de Broglie wavelength. The mathematical expression of de Broglie wavelength is given by lambda equal h by mb, and this is equal to h by p. Okay, where lambda equal de Broglie wavelength or matter wavelength, h equal Planck constant, m equal mass of particle, b equal velocity of particle, p equal mb. This is equal to momentum of particle. Okay. De Broglie hypothesis. In 1924, de Broglie suggested that every moving particle associated with wave. According to this hypothesis, a moving particle sometimes acts as a particle nature and sometimes acts as a wave nature. Okay, and these types of wave is called de Broglie wave or matter wave, and the wavelength is also known as de Broglie wavelength. The mathematical expression of de Broglie wavelength lambda equal h by mb, and mb This is called momentum, because we know that momentum is equal to mass into product result of mass into mass and velocity. Okay, so lambda equal h by mb, and this is equal to h by b, where in this equation lambda is called de Broglie wavelength, m this is equal to mass of the particle, and b velocity of particle, and p equal mb momentum of a particle. Now we are going to derive de Broglie hypothesis. Okay, derivation of the hypothesis. According to Max Planck quantum theory, the energy of photon is given by E equal h nu. Suppose this is equation number 1. Also, from Einstein's mass energy relation we can write E equal M.Sc square. Okay, from 1 and 2 we can write h nu equal M.Sc square, and h nu we can break in terms of hc by lambda, okay, and this is M.Sc square, e square and c cancel to each other. Now we can write h divided by lambda equal mc and lambda equal h by mc. So suppose this is equation number 3. This is equation number 1, this is equation number 2, and this is equation number 3. Okay, this is known as de Broglie wavelength for photon particle. Okay, now if photon particle replaced by matter particle, then equation 3 we rewrite lambda equal h by mb. So suppose this is equation number 4. Equation 4 implies that this is de Broglie wavelength of matter particle. Okay, first of all, according to Max Planck quantum theory, the energy of photon, as we know that energy of each photon is equal to, according to Planck quantum theory, E equal h nu. So this is our equation number 1. And from Einstein mass energy relation, this is very famous formula, E equal mc square, this is equation number 2. From 1 and 2, this is the energy of the photon, this is also energy of the photon. So from 1 and 2 we can say that h nu equal mc square, and h nu we can break in terms of hc by lambda, c and square cancel to each other, so h by lambda equal mc. Okay, h by lambda equal mc, and after cross multiplication we can write lambda equal h by mc. This is equation number 3, and this is known as de Broglie wavelength for photon particle. This is called de Broglie wavelength for photon particle. Okay, and now if the photon particle replaced by the matter particle, then equation number 3 we can rewrite C equal B at the, in this situation C equal B, then we can write lambda equal H by MB. This is equation number 4, and this equation number 4 implies that this is the de Broglie wavelength of matter particle. Okay. Now the following important points are worth noting about de Broglie wavelength. Number 1, so we know that lambda equal H by MB. If M equal 0, then lambda equal infinity. Okay, and if B equal lambda equal infinity, if B equal 0, then lambda equal infinity, and when lambda equal infinity, then B equal 0. It implies that de Broglie wavelength associated with only moving particle. Okay, and number 2 important note, de Broglie wavelength is independent of charge of particle and nature of particle. And number 3, de Broglie wavelength inversely proportional to mass and velocity of particle. Mass m and velocity v of a particle. It means that lambda inversely proportional to m, also lambda inversely proportional to 1 by b. When mass of particle increase, then lambda also decrease, and when velocity of particle is increased, then lambda is decrease. Okay, so the following points are worth noting about de Broglie wavelength. Lambda equal H by MB. If we put the B equal 0 in this equation, then we can write wavelength is infinity, and again when we put the value of lambda infinity, then we can write B equal 0, and it implies that de Broglie wavelength associated with only moving particle. And second, de Broglie wavelength is independent of the charge of the particle and nature of the particle. It means that de Broglie wavelength does not depend on nature of particle and particular charge of this particle. Okay, thank you.